Next presentation from Donetsk Physical Technical Institute, Mr. Raspornya. Do you have a scientific degree? Not yet. Доброго дня, пані та панове. Мене звати Дмитрій, я з Донецького інституту фізики та інженерії, фізичного інженерного інституту. Я хочу представити звіт про отримання модифікованих титаніумових сплавів. Я розкажу про медичне застосування цих матеріалів.
Institute from Department of High Pressure within government program for nanotechnologies and nanomaterials. Here is the outline of my report. As you can see, I will tell you about product. I will give you a brief description of the technology. I will tell about the situation with intellectual property, and I'll try to show what can we propose now for the investors, and give you some market information in figures. So first of all, the product is modified titanium alloys for medical application. They have increased static capacity up to 200%, as well as increased fatigue strength, higher structural homogeneity and absence of anisotropy, as well as enhanced processability that allows to treat precise details, and due to refinement of the structure, they have better biological compatibility. Ladies and gentlemen, here is twist extrusion on this on this picture. It illustrates how this technology works. Twist extrusion is the basic method for this technology. The main feature is the powerful vortex flow within the deformation site. This is actually severe plastic deformation, and within the deformation site we have a powerful vortex flow, which leads to the grain refinement, and after that increasing of exploration characteristics of mechanical properties, etc. We have within this work we have already received 5 Ukrainian patents, 3 patents of Russian Federation, and 2 international PCT applications are submitted in order to achieve patents in some countries where we are going to develop this technology up to productive chains. Our eyes now turn to Israel and Switzerland, because it seems that now we are very close to find partners in those countries. In particular, we have talks in progress with Dr. Anna Heinze, who's the head of R&D department in Nobel Biocare. I'll show you later what Nobel Biocare means. This is some peculiarities and advantages of the technology. We can obtain new structures because of exact 90 degrees between axis of billet and plane of simple shear. We can reach a high level of homogenization. It's something like reason for us to be proud of our achievement, because we can process profile samples that is impossible for any other SPD technique, such as, for example, ECAP. You have been heard about this technology today. Professor Valiyev, Ufa University, they have in equal channel angular pressing, ECAP, and this technology doesn't allow to treat profile samples, as well as decrease of material losses, because ECAP is has a very huge material capacity. After each pass, they have to cut about 30% of the material. It's a feature of its technology. And it should be emphasized that our technology could be integrated in existing productive chains. We do not need for the construction of some new equipment, just to some part of devices for integration in existing productive chains. Now we can propose different types of collaboration. Licensing, it means that we can conclude a license agreement with end producer who wants to produce their medical implants with help of our technology. We also can propose startup creation together with investor. We can register startup company, and after some necessary development, we can sell this company to the huge manufacturers. And the third one is the joint venture. We can share our technology with the investor, and our part of income will be caused by the by our intellectual property. Some market information. It's for you to decide if it's really a prospective market or not. I will give you only facts. Morgan Stanley reported that in 2012, the market of just not all their medical implants, just dental implants, was $3 billion. And now there are 236 companies producing dental implants. For each of those who is not in top six means that guys, and here is Nobel Biocare. It's the hugest one of all of the producers. So for every company who is out of top six, average net income in 2012 was about $3 million. And if the new company will catch only 1% of the market, its gross receipt will be about $30 million. Our next step, actually, green one is already completed. It's a pilot technology developed by our researchers. We are going to make a commercial prototype, and after that, manufacturing technology in order to bring it to productive chains. So investments are welcome. And at the end of my speech, I will say about how the way we are going to impact on the market. This is the field for making some conclusions. Expanding of products range will be caused by overcoming of some technical limits. That is why we prognose the increasing of sales volume, because there will be much more people who can apply some kinds of implants because some technical limits will be denied. And at the end, creation of new segment of high quality production will be caused by successful and sustainable demand for nanotechnologies, for nano brand. And that is all. Thank you very much for your attention. I'm ready for answering your questions.
Thank you, Dmitry. Any questions to Dmitry, please? I don't see. Please.
Будь ласка, скажіть, який максимальний розмір тих заготовок, які ви отримуєте після виготовлення цієї технології? Максимальний розмір заготовки наноструктурної.
Наразі максимальний розмір в межах дослідної технології це 70 см. В межах commercial prototype це буде від 1,5 до 3
It's going to be 1.5 to 3 meters size. We know that almost all companies who produce implants, they work with long length billets. Therefore, it's our goal, it's our next step to make the longer billets with this same technology. And what is the shear? The shear is 23 by 40, so 23 millimeters in diameter will result in direct extrusion. So as an example of how many companies can produce dental prostheses, 236. And the Donetsk company just presented us that they created their own system. So you have to really compare. Most of the presentations state that we are the only ones. And this example leads to many doubts. Different materials, different ceramics. Okay, let's leave that for the discussion. Now, this is a comparison of competences. Okay, I've had two questions for the presenters, and the question from the internet. Dr. Pirko, how do you prevent oxidation of silver nanoparticles? The oxidation of our silver nanoparticles the nanoparticles were protected against oxidation by the particles that helped create them. Another question to Mr. Lysenko: whether the amount of nitrogen in your diamonds allows to see any singular defect of nitrogen, and what is the fluorescence resulting from it? Please use the microphone. Okay, thank you for this question. We currently have diamonds with nitrogen concentration lower than 10 to 15 per cubic centimeter. So those are the diamonds that are used for research and fluorescence. Unfortunately, we're just preparing for these experiments. Thank you.